to today's webinar. We have been doing quite a lot of work at the MTA around industrial decarbonisation and talking to members and trying to find out a little bit more about what the requirements are. Today, I'm delighted to say we have been joined by Warwick Manufacturing Group, who have been doing a lot of work on this area. We're going to go through some practical case studies today. We're going to talk about data and data analysis, and again, those how energy reduction leads to reductions in scopes 1 and 2 emissions. If all of that sounds like gibberish, don't panic, that will be explained as we go through. If anyone's got any questions throughout today, you can either use the raise hand function or the chat function. I will keep an eye on that and I will relay those to our presenters at the end. So I am going to shut up, you'll be very glad to know, and I'm going to hand over now to Russ Hall from WMG to introduce himself. Russ, over to you.
Morning. Thanks for the introduction, James. Very flattering introduction, I think. I'd like to introduce my colleague, Felix Martin. We'll do some formal introductions in a minute when we get into the presentation slides about who we are and why we're here talking to you. We're really happy to be talking about the subject. It's something that's not only a research area of ours, but something that I think Felix and I have become increasingly passionate about in the past couple of years. The reasons why we do it and the reason why Warwick Manufacturing Group is the wants to talk about this it is from a perspective of we want to save the planet, we want to make the environment better, but we also want to make sure that there is a future for UK manufacturing. And I think at the heart of this is not just a sustainability message in terms of the environment, there's a sustainability message that sits at the heart of how we get manufacturing to not only survive, but also to thrive within the UK. Right, so without further ado, I will share my screen. Let's put that over there. Excellent. So, can I get a thumbs up from someone to say they can see the screen?
Yeah, that's all good.
Perfect, thank you. Okay, so Warwick Manufacturing Group. Warwick Manufacturing Group is a faculty of the University of Warwick. We are host to one of the high-value manufacturing catapults. We are here. What I always say is that Warwick Manufacturing Group is here to make manufacturing better. We are a technology solution provider in the applied research space. So we do fundamental research from technology readiness levels 1 to 3, but primarily what we do is applied research in the technology readiness levels of 4 to 7. Felix and I very much work in the applied space. We work with real businesses. Our applied research, our fundamental research is much more limited. We do work alongside some academics who do some more fundamental research, but it's very much not what we focus on. What Manufacturing Group is, when you ask outside of sort of here, for people who've heard of it, typically what they will say is automotive. And they'll say it's automotive is what it's known for, it's what we do. Really, that's not quite correct. When Warwick Manufacturing Group was started in 1980, it did have a huge automotive focus because of what was going on in the West Midlands at the time. We've now moved on significantly, and I think it would be a good way to sum up what Warwick Manufacturing Group is good at and what it knows is we're good at electrons. So we know how to move them around. We know what kilowatt hours are. We understand what energy is, and we understand why it's important. We also recognize that the world is changing. So whereas before, when we talked about automotive in previous years, what we would have had is a world where we were burning fossil fuels in order to make those vehicles move around. We're now looking at electrified vehicles or low carbon gas vehicles. And for Warwick Manufacturing Group, well, we're very good at batteries. We understand the energy that goes into moving things around, and we understand fuel switching for vehicles. If you understand fuel switching for vehicles, to a large extent, you also understand it for industry as well. What we need the world to do in order to decarbonise is to move away from burning fossil fuels for its energy and move towards lower carbon ways of doing it. Sat in amongst that is doing things more efficiently. And what we're going to talk about today is why energy efficiency is really important, how it relates to emissions, how it's something that is a relatively easy thing to do in principle, but actually requires a huge amount of data in order to make it meaningful. And Felix is going to talk about a great case study that we did with a company called Castellum, and he's going to take you through the data that we use and how we managed to relate that to not only emission savings but also operational cost savings, and give you some real numbers to show just how powerful it can be. Who are we? Well, I'm Russ. James did a great intro for me to give you my name. I'm the lead for industrial sustainability for the High Value Manufacturing Catapult and Warwick Manufacturing Group. I have a background in heavy industry. I actually started off in oil and gas, making things dirty, and I've ended up in sustainability, making things clean. Primarily, I've moved from oil and gas into energy has always been a theme. So I moved from oil and gas, I moved into heavy pressure vessels for liquid gas storage. Then I moved into the nuclear industry. Then I moved to the steel industry. And I ended up 8 years ago working for the University of Warwick at Warwick Manufacturing Group. And I suppose I would describe my job now as a little bit of research, but mostly professional networking. I like to think I have an expertise in industrial decarbonisation. Across the network for HVM, everybody really knows me for carbon accounting and emissions measurement. Felix, all yours.
Thanks, Russ. Hi, everyone. My name is Felix Martin. I'm a lead engineer here at Warwick Manufacturing Group. I've been here for 6 years. My background is in automotive and manufacturing, and I have expertise in industrial decarbonisation, technology, feasibility, fuel switching technologies, data analysis. And yeah, happy to be here and talk to you about the project we did with Castellum.
So just going back a step to make sure that we're all on the same page. What is industrial decarbonisation? Industrial decarbonisation is not net zero. Industrial decarbonisation is a subset of net zero. Net zero means that on balance, the emissions that are emitted by society, by industry, by whatever you want to call it, are on balance zero. Industrial decarbonisation is about the reduction of emissions. There are 3 different kinds of emissions according to the Greenhouse Gas Protocol. Scope 1 emissions are direct emissions, and if you think about a very personal example, it would be the carbon dioxide that you breathe out in every breath. So that would be an example of a direct emission from a human being. From a factory, it would be if you're burning fuel on site, if you have trucks, diesel trucks, or petrol vehicles moving around a site, they would count as direct emissions. Scope 2 emissions come from purchased energy and steam. So if you're buying electricity into your home, the emissions that would come from burning gas to generate that electricity are the indirect emission that's for scope 2 that's associated with it. And scope 3 is everything else. Scope 3 is the indirect emissions that come from the things that we buy, the supply chains we use, the products that we make. They are really hard to calculate and they are really difficult to understand, particularly downstream. Upstream, manufacturers usually understand their supply chains relatively well. They know where they're getting things from, and that gives an indication of what you can ask for. Downstream scope 3 emissions are much harder because that's the product that you make. So if you take a mobile phone as an example, we've all got smartphones nowadays. If you choose a manufacturer who makes a smartphone, they can control the emissions and the energy that are used in how that smartphone is made. But what they can't do is control what you do with it. So if you choose to set it on fire or you choose to throw it in a river, that's up to you. There's nothing they can do about that. All they can do is minimize the impact of what the materials used to make that smartphone might do. So upstream, easier, downstream, really hard. To understand what decarbonisation means, you also really need to understand what the term carbon means. So we throw the term carbon around at WMG. It's like one of our most popular terms, but often people don't really know what it means. And I have been taken to task in the pub several times, to be honest with you, about this, as to why do you only talk about carbon? Well, we're not just talking about carbon, we're talking about carbon equivalent, so CO2e, and that's the 6 main greenhouse gases. There are actually 23 greenhouse gases, but there are 6 that cause most of the environmental damage, and they're the things that we talk about. So the diagram on the right, that's taken from the Environment Agency in America, is the same one that you'll find in the Greenhouse Gas Protocol, and that is the best diagram that I think there is out there for explaining what Scope 1, 2, and 3 emissions are. Why do we need to decarbonise? We need to do it for lots of reasons, really. One, I think anyone who's on this call would probably agree it's the right thing to do. So there is a moral obligation to do that for the future of the planet. And, fundamentally, we all like clean air. So if we decarbonise, we're all going to have cleaner air. We'll be taking those greenhouse gases out of the environment, and it'll give us a better air to breathe. Demand and legislation for lower carbon products. I was actually talking to a chap called Owen Lowry Smith from the Department of Energy Security and Net Zero. The government is starting to develop policies for low carbon products, and they will be voluntary to start with and then become mandatory. And as those policies come into place, that will put an even bigger demand on low carbon products for the future. Decarbonisation is connected to government growth plans. If you look at the clean energy superpower bid that Ed Miliband's been talking about, you look at how they want to get there, how they decarbonise the Scope 2 energy, the electrical energy, and that you buy into your businesses. That is the growth plan for the UK. That's how they plan to grow big supply chains and how they plan to drive manufacturing growth for the UK. We have targets associated with climate change, so 68% reduction of emissions by 2030, net zero by 2050. They are legal targets, we are bound to, and they are therefore things that we all must play a part in delivering. And of course, really, it's an opportunity. It's an opportunity to not get left behind. The CEO of a company called Granger and Worrell said to me, the reason why they want to decarbonise is that the companies that they sell their products to have asked for decarbonised products, and they're worried that if they don't do it, they will get left behind because they will go to manufacturers who say that they can. So we want to help companies like yours, like theirs, in order to go on this decarbonisation journey and to understand why it's an opportunity for everybody. So if we say that decarbonisation equals opportunity, the question that everybody should be asking is why? Decarbonisation should mean lower costs. It doesn't always, and there are exemptions, but for most operating processes, decarbonisation usually means energy that you use or you burn or you use on site, and you get it from either burning fossil fuels or from buying energy in, has a carbon cost associated with it, and it has an economic cost associated with it as well. If you can going to reduce carbon, you normally start with thinking about how can we reduce costs. And one of the best ways to reduce your costs is to reduce your energy bills. They are the current government published prices for a kilowatt of gas and what a kilowatt of gas equals in terms of carbon equivalent. You don't need to be a rocket scientist to understand that, as understand the relationship between the two. But it's surprising how many companies either don't understand it or have been treating energy almost as a throwaway commodity, if you like. Well, energy was cheap, it was easy to waste. But energy is not cheap anymore. Energy is really expensive. When the Ukraine was invaded and we saw a spike in energy costs, this work took off. And we had a lot of knocking on our door asking to understand it more. Not so much from a reducing carbon point of view, but from how can we be more efficient with our energy? How can we use less point of view? As energy has become cheaper, people have started to ask for less. But we're seeing more in the way of environmental controls coming in, and we're seeing more interest in the decarbonisation aspect for industry. And it all comes back to the same thing. If we can reduce the energy or change the energy we're using, we can reduce those emissions. We don't like to look at it from a theoretical approach, though. We really like to look at it from a very much a pragmatic, practical approach. Decarbonisation of whatever it is that you're doing shouldn't be difficult. There is a hierarchy of ways of doing these things to look at so, and you'll get different answers from different people. But we are sector agnostic. We are truly independent. Technically, you pay our wages, I suppose. So we want to give you the best service that we can. For a manufacturing business, the first thing to do is to identify the highest impact areas and then to identify what can be done quickly. If you're a foundry, putting LED light bulbs in is a solution that will help you to decarbonise, but it's probably not going to move the needle. If you're a cafe, it's going to make a big difference. So it's about figuring out what you're using energy for, what you can do fruit, if you like, before we get to the difficult stuff that you might need new technologies for. Energy efficiency and energy assessment is always a good first step. A lot of businesses do it. A lot of them. I think Felix would agree is probably Toyota. Always watch and see the list of their priorities, and they use percent of the by just looking at efficiency. So I don't have easy things to do. I think it's safe to say. And the right technology, the right purpose. So that can be really simple. It can be as simple as putting sensors in and understanding what to turn off and what to turn on. It can be about recovering energy that's currently wasted. So as an example, if you're wasting heat from furnace flues, well, how can you recover it? What's commercially available now, and what's the stuff that we need to do in the future? When you put it across in a simple way, everything sounds easy, right? So it's an easy prospect. Why isn't everybody doing it? Not doing it because actually you can't measure it, you can't improve it, and you need data. You can't. We need to start gathering that data to see what's important for businesses to look at. And the case study you're going to talk about today, Felix is going to go through, is a company called Castellum. And Castellum is a Shropshire-based British success story, really. They make really complicated aluminium castings, like the one you can see on the right. They supply fully finished high-pressure die castings for the automotive industry. And what's interesting about Castellum for me is this. They said, before we went to visit them, that they didn't think it was possible for them to get any more efficient because they've been hammered on cost by the automotive industry. And that meant that there wasn't really much more than for them to do. But as Felix is going to tell you, actually, when you properly look at the data, it's really clear that in terms of decarbonisation and cost saving, there's a lot that they could do, and they're now starting to do. They spend 7.5% of the revenue spent on energy. That's a big number. Felix can tell you the exact number. 69% of energy is used on gas-fired melting furnaces. And they are getting pressure from the OEMs they work with in order to decarbonise their processes. Felix, shall I go to the next slide?
Yeah, thank you, Russ. Yeah, so I think I'm gonna, as Russ said, I'm gonna spend the rest of the presentation just talking about kind of a concrete case study project that we worked on, to kind of put into context what we mean by the importance of data and so just to put into context, Castellum and our relationship with them, I think when they're using and I think the good thing about reducing your energy consumption means you can save money, but also save emissions at the same time, which is kind of a great thing to be able to do, and also kind of understanding your process kind of really important, production and production efficiency, and the overall health of your business. And we found that understanding the energy flows through your company, through your processes, was actually like a really good proxy for for understanding how your business worked and how your manufacturing processes worked, and looking at those in kind of a slightly different lens to what you're used to day in, day out. And then I think for Cast Atom, what the link to us was, they really they had data set for the energy that they had been using, which they'd collected over the years, and we had this opportunity to look at that data set through some internship that the NGO was running at the time. So basically, we had the paid resource available to work with them, really kind of dig into that and support their goals in terms of looking at that data and seeing what the opportunities were for industrial decarbonisation. So the outputs I'm going to talk about for this presentation is actually the outputs from that internship. The intern that we supervised, the findings that they ended up getting, and what we kind of actually ended up working on with Cast Atom. So if you go to the next slide, Russ, and again, so I'll just get into it. I mean, was basically it. This was the data set, the initial data set that they had. It's very high level. It's for their whole site, and it was actually just an energy data set, and you can convert that pretty easily from energy data into emissions data, and you can see emissions from Cast Atom over the years from 2010 all the way to 2024. So you can see quite a journey there in terms of emissions, but also in terms of Cast Atom as a business. And even this, I could spend half an hour talking about the quirks of this graph, but I think fundamentally, you can say, oh, it's quite positive. Their emissions were just over 0.8 kilograms of CO2 equivalent per year. That's to the power of 7, and kind of reduced down almost by half by 2024. But obviously there's a lot of context in there that you kind of need to explore. Obviously that there's a big dip in 2020, presumably caused by COVID. There was a bit of a slump in the automotive sector, and I think what that really shows is that potentially energy efficiency and decarbonisation or measures aren't necessarily the number one thing that affect how you reduce your energy use. Actually, you could infer from this graph that maybe it's just how healthy you are as a business, how much your output is, how much your production is, and so it's really important to actually understand those factors when you're looking at energy data, when you're looking at energy efficiency, and it's always important to kind of see those different contexts. So if you go to the next slide, Russ, you can kind of see what we thought then was a logical next step. So if you have your absolute emissions number of this is how much our whole site is using over the years, but we know how dependent that is on our productivity and how many castings we're producing, for example, for this foundry business. We can try to put those emissions figures into context of relative to our production. So in this case, we basically looked at the kilograms of CO2 emitted per net weight cast. So that's just one of the metrics that they use to track their outputs. And you could see kind of a much smoother graph than the last one. So you can take out some of the irregularities caused by the changes in the business. And you can actually see what I would consider quite a positive trend in the way that this business actually reduced the amount of energy or the amount of carbon that they were emitting per unit of output, which actually I think was really positive for the business. And even just this, you can kind of see at the end they end up getting a number for the amount of CO2 per kilogram weight, and that's something that they've started using then when they were talking to suppliers and customers. So if they, as I said, they work a lot in the automotive with automotive OEMs. And when those customers start to ask about, well, what actually is the embodied carbon of our orders, of the parts that you make, this is the kind of thing that you can use to get a first estimate of what those numbers are, and even just this output was something that I think Castellan found quite useful, and for SMEs is not something that necessarily is available right off the bat. So if you go to the next slide, Russ, I think when we started looking at the previous slide on kilograms of CO2 emitted per unit production, what we found is that actually production is actually a really, really important part of how much emissions you produce as a manufacturing business. And so we tried to kind of look a little bit more in more detail about how production changes over the year for a company like Castellan or for a manufacturing SME, and try to get more of a handle on how that actually affects emissions, energy use, and costs. So on this graph, you can actually see all of the different parts are a different band, color band of the different parts that they produce. And kind of the sum of them all gives the sum of the total outputs for this manufacturing SME. And running a manufacturing SME or working for a manufacturing SME, kind of you will probably recognize that these peaks and troughs are probably quite common in the business, but actually from a operational perspective and from an efficiency perspective, they're really quite suboptimal. So ideally, you would want to have a very flat line around the 700k mark, and run that for the whole year, because it means you don't have to pay overtime, for example. You don't have slack in the system, but also from an energy perspective, you don't have to stop and start processes so much. You can have much more continuous operation, and from an energy perspective, that's a much better way of running things, and it's another way to reduce the amount of energy you use. But this again is something that this insight is really something that only comes when you take a step back and look at it holistically, and break the kind of cycle of always just doing things, putting in orders as they come, and trying to take a step back and seeing what the usage patterns actually are for a whole year and for the business. So if we go to the next slide, please. There's another way of kind of combining then energy and working patterns, and that's, I think, something that we learned was a really powerful way of looking at how energy was being used, but also how you can take the expertise that SMEs have in the way that they do business, and combine it with data, particularly energy data, to see if there's kind of these are kind of potential areas we want to look at in a bit more detail, because we don't think the patterns kind of match up to our own expectations. So I think that's kind of a real big takeaway for me for this project, was really basically using data to start conversations with the people on the shop floor, with the people in the business, to really kind of understand the way that energy and production was being used in a much better way. So this graph shows half-hourly electric consumption across a week. So you can see how this company is really doing kind of the normal work week on Monday, Tuesday, Wednesday, and Thursday, and then on Friday they would have kind of a half day, and on Saturday there would be a bit of overtime. That's the brown line, and on Sunday the pink line is kind of basically where no energy is, well, where normally no energy is being used, there's no production, but you can use this to look at things like base loads. If you find that even on Sunday where nothing is being produced, there's still kind of 250 kilowatts of energy being used, you can start to kind of investigate, is that a base load that we're happy with? What are the machines and things that are causing that base load? And is that something we can look at to address? And similarly for the other days, if there's kind of spikes or if there's daily variations in the way that you use energy, you can know what your average is and what you would typically expect for a given day in a given week, and use that to contextualize how you actually work on a day-to-day basis, and again use this to identify opportunities for energy efficiency improvements. So yeah, I think all of those were kind of super high level ways of interpreting a data set that basically is just site level data, and you can just use those data sets to infer actually already quite a few things and find quite a few different insights. But then we went on to look at actually what are the are there micro insights we can look at? Can we look at machine data to find the way that energy is actually moving through our site and how we're using energy on a machine level to see where that energy is actually flowing and where that energy is actually going. So that's the thing that we did next. So if you go to the next slide, Russ, and again, you can see that what we did then was we tried to break that high level figure down into the underlying machines that were actually causing that or that made up that high level energy use. So the way that Castellum as a business worked, they actually have 14 of these die cast machines. Those are their big users of energy, and also they're big, obviously, like manufacturing machines. So there's 14 of them that are basically identical, and there was kind of an understanding of the way that the different parts of that machine used energy based on kind of anecdotal experience from the people that used them, the rated power of the different machines that made up that larger unit, but there was no real real-time understanding of how energy was being used and how that was broken down, particularly seeing as level. So there was no knowledge of, has that energy consumption changed over the years? How has it changed? Are we using energy? Is your energy being used in the right way? So we basically tried to sub-meter all of the different machines that made up that larger unit, and break down the energy uses of the different machines. And this is what the graph here shows, with kind of some hydraulic presses, some pumps, some trim press, that kind of thing. And what we noticed when we actually worked with this company was that the trim press is the green line, and it actually has this base load of just under 5 kilowatts that was really unexpected, I think, for this manufacturer, because really, the trim press just actuates every once a cycle, and so the base load was really unexpected. And what you find is when you have base loads even that are very, very small, so just under 5 kilowatts, if you extrapolate that out across a business, so you have just one trim press that's under 5 kilowatts, but then you have 14 of these die-cast machines, and they're operating 6 days a week, and it's operating 48 weeks a year, though the cost of 5 kilowatts extrapolates quite quickly, and you're left with kind of just under around £133,000 in electricity costs just from this kind of base load. And this is something that the company really wasn't aware of. And I mean, we weren't aware of going in with this project. But these are the kind of things that you can find and look at and address when you really look at energy and energy flows through your processes in a lot more detail. So if you go to the next slide, Russ, I think I just wanted to sum up in terms of what we get out of using data in a more effective way, and really what we get out of understanding energy flows through the site in a better way, is that I think what we found is we investigated the production patterns, but what it meant is we understood the carbon impact of the individual machines, of the individual processes, and of the whole site and manufacturing kind of hub in a much better way. It meant communicating with the different stakeholders was a lot easier. So stakeholders could be your customers, so the big OEMs, but it could also be kind of people on the shop floor. So you can use this to talk to the people that work for you and really show that the things that they do, the little turning off this machine actually has this much impact. Turning off this machine has £50,000 worth of impact. And all of a sudden is a much different conversation to just saying, "Oh, come on, just turn it off," and we don't really know what the impact will be, but it's the right thing to do. This showed some real opportunities for reducing energy costs. It made it really easy to find the equivalent of what those energy reductions were in terms of energy emissions from that energy. It made it much easier to quantify investments and start to build business cases. So Russ said right at the start that just under 70% of their energy comes from their melting furnaces and from their furnaces. Those furnaces are all really old, so it's worth looking at replacing them for more up-to-date, more efficient units. But you can't build a business case if you don't know how much the energy of those units currently costs. So you need to have a really good handle of how each machine uses energy, what the associated costs are, so that when you reach out to a supplier and get some questions for how much you actually are going to save in terms of energy, you can then turn around and say, well, we are currently using this much energy. If you're saying we can reduce by 30%, then this is what it actually means in terms of energy savings for us. And that is the only way you're ever going to be able to build a business case around energy efficiency improvements and technology changes and technology upgrades for decarbonisation. And the final thing is kind of around regulatory compliance. So for businesses above SME, larger than SMEs, there's something called SCCR, which means that companies have to report on their energy use and on their carbon emissions. I think that is something that potentially be rolled out to SMEs as well in the future. And so having a good understanding of the energy you use and of the emissions that is associated with it is something that could be of regulatory importance as well. Obviously, CBAM comes into that as well, potentially. And there are kind of reasons why having a really good understanding from a regulatory perspective is also a good idea. So just to conclude on my final slide, Russ, if you can go on one more. I think these are some of the takeaways that Castellum actually had that I'll just read out to you. So from their business perspective, I think the overall improvements as a general trend over a period of data was something that was a good takeaway for them. So they were happy being able to see that actually they have improved their emissions over the last 10, 12 years, which was a big positive for them. I think so alongside analyzing raw data, Castellum needed to examine the business evolution to achieve greater understanding. So that's the piece I mentioned at the start around putting that raw data into context of where the business is at and where production is at. I think if you just look at it from a raw absolute terms, there's lots of actual factors that can affect the energy that you use and your emissions. So it's important to understand the underlying factors that affect that. Question your own expectations and results. I think, again, for Castellum, there was a big expectation that they had become a lot more efficient, energy efficient throughout the years, which I think was probably true. Actually, no, it was true. But as it turned out, that in this large kind of raw data set, it was quite difficult to see that because of all the other things like business factors, like the decarbonising electricity grid, that really kind of can make that less clear. And so, yeah, it's always good to question your own expectations was something that they said. And then finally, beware of Pandora's box. I think for Castellum, Carl, the MD, is really enthusiastic about this topic, which is, I think, one of the reasons why this project was such a success, was that he really supported it and that he realized that how important energy was for their business. But what it also meant was kind of we answered a lot of questions with this project, but we also had even more new questions that we generated, and so I think it was really good for Castellum because they they learned really a lot about their processes, about their energy that they were using on their site. And also, I think they learned a lot of the unknowns that they still have in their process, which I think is can only be a positive for them going forward. And I think it's definitely something that they took away in a positive way. And hopefully, I think I think we will continue working with them. We have another follow-on project to look at something similar to this. Yeah, I think it's hopefully the people watching this presentation can also take away. So I think the final slide is for us to conclude. And back over to you, Russ. Thanks.
Thanks, Felix. What we tried to show, I hope the takeaway messages are that energy is related to emissions and it is related to cost. And if you can bring one down, you'll be able to bring the others down. But decarbonisation really is an opportunity for manufacturers to grow, not just because low embodied emissions, low carbon products are coming into more demand, but because actually, if you save cost, if you save energy, you give yourself more operating cost in order to play with, and that can be used for whatever you want to use it for. It has another word which is technically profit, I suppose. There are technical and non-technical barriers to decarbonisation, and I think Felix indicated these really well as we talked about as he talked through the Castellum case study. The technical barriers are: can you measure the data? Do you know what it is? Do you know what you need to do? Do you know what the technologies are that are required in order to get to decarbonisation? But the non-technical barriers are often harder. And those non-technical barriers are you talking to machine operators? Do they understand the reasons why you're asking them to do the things that you're asking them to do? Do they understand what the message is and why this is tied to the health of the business? Net zero, decarbonisation, depending on the paper you read, gets good or bad press. It is seen as something that is either positive or negative for business. Rarely is it presented as something in it, as rarely is it presented in a balanced way as something to say, there is an opportunity, there is something for us to do, but we need to do it the right way and it needs to be considered. Anybody watching this watching this webinar, is more than capable of having that discussion. And we have lots of case studies that we can draw on, and when it's done right, it's really effective for businesses. And it doesn't have to be driven by passion, it can be driven by straight economics if that's what's needed. Energy efficiency is a low-cost way, can be a low-cost way to reduce emissions. And it's actually probably the easiest thing to do in a lot of ways because everybody can be more efficient. But everybody assumes that they've done everything that they can, and that's not always true. Why is it low cost? Well, one, because it saves you money, but two, because the technology that you need to do data analysis is really cheap. You need a computer, you need a clever person, and you need some energy sensors. The energy sensors that we use can be connected and disconnected in seconds. So it's not something that you're not major capital data measurement. You are breaking into gas lines for sure, but if you want to do electricity measurement, actually it's a really cheap and easy and effective thing to do. There are consultancies out there that can help you with it. It's something that's well worth having a look at. As Felix has shown, data is key. Now, we were really lucky with Castellan because they had existing data that went back over years. And if we look at the other analysis that we've done of factory loading against time, of how energy can be used, and how it can be related to productivity, it really is Pandora's box. You end up opening a huge raft of information. But you can't do it without data. It just doesn't work because you don't know if you're going to be looking in the right places. And it's easy to be bamboozled by people who will give you advice, and that advice may be wrong. So be careful, get your own data, do your own analysis, don't make assumptions. Castellum is a great case study of how you can use existing data. That work with that company has continued, it is growing. We now have a KTP, knowledge transfer partnerships already being signed up with them. They are one example of many companies that we are working with of different sizes, different sectors. We've done work. A lot of our work is with foundry industries with high energy users. But we're also starting to look at additive manufacturers. We're also starting to look, we've even had conversations around things like data centers about how these approaches can be used. So I hope that gets the message across that decarbonisation is an opportunity. Reducing your emissions is a way to make your business more healthy, and we'd be happy to take any questions. Thank you. I'll stop sharing.
Guys, thank you both very much for that. Very much appreciated. As mentioned at the top, if anyone's got any questions, please use the raise hand function, or you can drop it into the chat and I can relay that. A question just to start us off then. If you are an SME and you are starting on this journey, what would you say is the first place that you can start at? What's the kind of base point, I guess, for starting on this sort of project?
Felix?
I think, well, from an energy perspective, you can get just energy, the amount of energy you use from your bills. Everyone's got that. The second thing you can do, you can request half-hourly data from your energy supplier. So that'll be more granular data. All of that is free. You just need to take the time to look at it. And then try to compare that, I would say, to your production. So if you have data on the amount of X units that you produce, even revenue you're making, then that can give you your energy use in context. Yeah, that's how I would start probably.
Cool, thank you. And do you find most people tend to do that exercise and set a target? We've seen it before where not within our membership, but we've had companies that have come along and said, yeah, we're going to be net zero. And I think the message I got there was kind of be careful you're not setting yourself up for a fall, because that's quite a big claim to make. Saying we're going to decarbonize and reduce energy, or reduce carbon consumption, for want of a better term, is often a better way than going, yeah, I'm going to completely be net zero by a certain time.
I think that it's really easy to misrepresent what you're doing. And I think you need to be careful with statements like net zero. So if you look at Castellum as an example, can Castellum ever truly get to being net zero? The only way they could do that is by either putting carbon capture onto their furnace flues, or by offsetting somewhere in their energy supply chain or their waste supply chain. And the accountancy for carbon around offsetting has been shown to be a little bit dubious. And the idea of small manufacturers being able to engage with things like carbon capture technologies, there is some cutting edge stuff coming out for small manufacturers, but it's not going to be around for a long time. So I'm always a little bit skeptical when manufacturers say that they are net zero. What I would say though is that setting targets on decarbonisation, reduction of emissions, as long as you're not too ambitious, that's perfectly reasonable. And there is government. The thing I meant to say in the presentation, I realised I forgot. There is government available data that allows you to convert your energy numbers and your material numbers to carbon equivalent emissions. And you can then relate that to cost, and that can all be done on a really simple spreadsheet. So it doesn't need to be complicated. You can set targets relatively simply. And I suppose I would love it if everybody went for the holy grail of reducing their emissions to fractions of what they're doing now. But we have to be realistic in what can be done in what timeline. I'd like to change the world overnight, but I appreciate that that's not necessarily true. So look at the data, see what there is, see what's reasonable, and see where you need help. And then help doesn't need to be expensive. It doesn't need to be consultancies. It can be people like us who will talk to you for free. There are other research and technology organisations available. This isn't just a plug for WMG as much as I feel I should do. So reach out and ask. Advice is free. Projects, we have to think about that because we have to have income as well, as does any RTO. But we can give advice for free. We are learning lessons all the time, and that information has been paid for by the taxpayer. So just reach out and ask, and we will do our best to help.
That was going to be my final question, funnily enough. If people want help, obviously they can come to you guys. Would you also be able to signpost them to others that could help as well?
Yes, of course. Yeah. So the High Value Manufacturing Catapult Network, this work is going on across the network, and we will, if we can't do it, we'll signpost to the right place. We don't work with every industry. We'd love to be able to work with everybody, but there just aren't enough of us. So we will point to the right place. If it's help with things like emissions accounting, we can point to companies out there that do that and do it very well, depending on what it is you want to do. Anything to do with that decarbonisation route for industry, if we can't do it, well, the right place, or we'll try and help you.
That's brilliant. Thank you very much.
We do have one project right now that is already funded, looking at like modeling energy for industry. So there might be a way there to get some like cheaper work done. I think probably at the moment we're looking at like joint funded models for that to work with industry, where we basically go in and model their energy flows and model their production site for a research project that we have. And it will be joint funded between the university and the industrial partner, I think is currently the goal. So if that is of interest, then please do get in touch as well. And we can work together in that way. But as Russ said, that doesn't have just ask the question, and we can find the best solution together.
Well, thank you very much. And if anyone needs any contact details, then obviously feel free to drop me a line and I can always forward on to the guys. So there are no other questions in the chat and I've not seen anyone raise their hand. So assuming that no one jumps in the next 5 seconds, I am going to end that by saying thank you both very much. That's very much appreciated. We are looking at putting together a series of webinars, podcasts on this topic. So if there's any specific areas you're interested in, then please drop us a line here at the MTA, particularly if you're watching this on catch up or on demand. Otherwise, thank you very much. And that's the end of the webinar. Thank you very much.
Thank you.
Thank you.